Uh, okay, today's lecture is devoted to the blockchain technology and its usage in the real banking practice. So it consists of the three lectures, and the first one will be pretty theoretical one about the blockchain technology in general. The second one will be devoted to the blockchain technology usage in banking. And the third one will be devoted to the payments and the based on the blockchain technology as well. If you have any questions, so please do not hesitate to put them into the chat. So if I'm able, I will answer them during the lecture or afterwards, after the lecture. Therefore, if you do not have any questions so far, so we can start on. Welcome everyone to our second module on blockchain technology and cryptocurrencies. And I'm excited to guide you through one of the most revolutionary technologies of our time. So in this module, we'll be exploring several key aspects that I believe are crucial for understanding the future of digital finance. And first, I will introduce you to the fundamental concept of blockchain technology, which is a fascinating system that's much more than just the backbone of Bitcoin, as you may know. And we'll delve into the decentralized nature of blockchain, which in my experience is often the most challenging concept for students to, I don't know, grasp initially. So I will show you how this decentralization creates a level of security that was previously impossible in digital transactions, for example. And I will also explain the cryptographic principles that make blockchain so secure. And don't worry if you are not a cryptography expert, of course, because I'll break it down into understandable concepts. And we will explore how these security features work in practice. What I find particularly exciting and what I want to share with you is how blockchain and its technology extends far beyond cryptocurrencies. And we will examine various real-world applications that are already transforming industries. And finally, we will look at different types of cryptocurrencies and their role in the digital economy as well. So I believe this knowledge will be invaluable for your future careers, for example. And let's begin this journey together into the world of blockchain and cryptocurrencies. So now, before we dive deeper into blockchain, so let me explain why we need an alternative to traditional banking system. So this is something I've studied extensively throughout my career in financial technology. And in our current centralized banking system, everything revolves around a single point of control. So while this might seem efficient at the first glance, but I wanted to think about the inherent vulnerabilities this creates, actually. And it's like putting all your eggs in one basket. So, and I've seen firsthand how this can lead to significant problems. And let me give you a concrete example. So, for example, when a central bank system fails, it affects every single transaction and account holder as well. So I remember when several major banks experienced, for example, system outages, and millions of customers couldn't access their money or make payments. And this is a direct result of relying on a single point of control. And moreover, the centralized nature makes these systems particularly attractive targets for fraud. And hackers only need to breach one central point to, I don't know, potentially compromise millions of accounts. And I have actually analyzed numerous cases where this exact vulnerability led to massive data breaches and to financial losses as well. And this fragility in our banking system isn't just a theoretical concern, it's a real issue that affects customers, consumers, trust, and financial stability as well. And this is precisely why I believe understanding alternative systems is really crucial for anyone studying modern finance. And finally, this vulnerability is centralized in the banking, within the banking, and it is what led to the development of blockchain technology, which we will explore next. The next slide. Now let me explain one of the most fundamental shifts in financial technology that I've witnessed in my career, and which is the move from centralized to decentralized systems. So when I compare traditional banking networks to blockchain networks, the difference is striking. Imagine, if you will, a traditional bank as a single castle with high walls, so impressive, but very vulnerable to focused attack. And now contrast this with blockchain decentralized networks, which I like to think of as thousands of smaller fortresses, each protecting a piece of the whole system. And in my experience of teaching this concept, so I really find it helpful to use this visual representation. And here you can see how centralized networks, for example, channels everything through the hub, and that's our traditional banking system. But if you look at the blockchain network here on the slide, the representation of the blockchain network to the right, so it's distributed across multiple points, making it inherently more resilient. And what is fascinating about this transformation is how it completely reimagines security. So when a transaction occurs in the decentralized system, it's verified by multiple nodes simultaneously. And I've seen this system withstand numerous attempted attacks, because even if some nodes are compromised, nevertheless, the network as a whole remains secure. And this shift isn't just about improving security, it's about creating more democratic and resilient, even a resilient financial system. And in my view, this is one of the most significant innovations in financial technology since the invention of electronic banking. The next slide. And now let me share with you what I consider to be the real breakthrough in blockchain technology, which is the distributed ledger system that powers cryptocurrencies like Bitcoin, for example. So in my research and practical experience, and especially with blockchain systems, I really have found that the true genius lies in how the ledger maintains its integrity. So you can think about this because every single transaction is recorded in multiple places simultaneously. And as I often tell, it's like having thousands of accountants all keeping the same exact records, making fraud practically impossible. So, and what is particularly fascinating is the consensus mechanism. So let me explain how it works in practice. When, for example, someone tries to make a fraudulent transaction, the system doesn't just rely on one authority to catch it, because instead of it, the network automatically compares all copies of the ledger, and if something doesn't match, it's immediately rejected. And I really believe this technology represents a fundamental shift on how we think about the money. For example, you can consider traditional cash. It's physical, and it can be lost, stolen, or counterfeited. But with the digital ledger system, we have something that's simultaneously more secure and more efficient, even. And the implications of this are numerous, because from my work, for example, with financial institutions, different financial institutions, I can tell you that many are already exploring how to implement this technology. And it's not just about cryptocurrencies anymore. It's about creating a new foundation for all financial transactions. The next slide. And now let me take you back to where it all began. So, which is the fascinating origin story of blockchain technology. As someone who has studied the evolution of financial technology, so I find this history particularly enlightening, because all started in 1991, and I think it's crucial for you to understand these beginnings, because two researchers, Stuart Haber and Scott Storntana, were grappling with a fundamental problem. That is how to timestamp digital documents in a way they couldn't be tampered with. So this might sound simple, but it was a groundbreaking challenge at the time, because it is really interesting is how they collaborated with Bayer, for example, during the following year in order to incorporate what we now know as Merkle trees, so named after Ralph Merkle, who patented them in 1979. So let me tell you why this was so significant. Because Merkle trees allowed for efficient and secure verification of large data structures, which is still a fundamental component of blockchain technology today. And when I teach this topic, I always emphasize that these early innovations lay the groundwork for everything that followed. And the concept of cryptographically secured chains of blocks were revolutionary. And though at the time nobody could have predicted how it would transform the financial world. So, and this background is essential because it shows us that blockchain wasn't created in a vacuum. It was built on decades of cryptographic research and innovation. And that is why understanding these roots helps us better grasp the technology's potential and limitations. So now let me tell you about the what I consider the most pivotal moment in blockchain history. Exactly the mysterious emergence of Satoshi Nakamoto in 2008. And this is where the story gets really interesting. Because what is fascinating is about this period is how one individual or perhaps a group, so we don't know for sure, managed to solve a problem that had puzzled cryptographers for decades, because Nakamoto's breakthrough wasn't just technical, it was conceptual. And they figure out, in other words, they figure out how to create a distributed blockchain system that didn't need trusted parties for verification. And in the years of studying blockchain technology, I actually have come to appreciate just how revolutionary this innovation was. So you see the real genius that wasn't in creating a new type of database. It was in designing a system that could maintain its integrity without any central authority. And this was something entirely new, I would say. So, what is remarkable here is how Nakamoto improved upon previous designs, because they created a way to add blocks to the chain that was both secure and decentralized. Because when I tell about when I talk about this, I often emphasize that this was the key innovation that made Bitcoin possible, even. And the impact of this development cannot be overstated, because, in my view, it marked the beginning of a new era in both technology and finance as well. Because it's not just about the technology itself, it's about fundamentally changing how we think about trust and verification in digital systems overall. The next slide. So now let me walk through the what I consider the first revolutionary phase of blockchain evolution. So the birth and early years of Bitcoin. And this period from 2008 to 2013 was absolutely crucial for the technology we use today. So, and here I want to clear up a common misconception I often encounter. That is, many people think Bitcoin and blockchain are the same thing, but they're not. And understanding this difference is crucial, because Bitcoin was simply the first application of blockchain technology, albeit a groundbreaking one. But when Satoshi Nakamoto released the first white paper in 2008, I remember how it sent ripples through the financial technology community, because what made it so revolutionary was its description of blockchain as an electronic peer-to-peer system. So, and here, let me emphasize this point, because for the first time, we had a way to transfer value digitally without any intermediaries. And the Genesis block, so that's what we call the first block Nakamoto created. It was just the beginning. And from there, other blocks were mined, forming one of the largest chains of blocks in existence. And in my analysis of this period, what's particularly fascinating is how quickly the network grew and how robust it proved to be. So, and this phase, in other words, laid the foundation for everything that followed. Because when I teach this topic, actually, I always emphasize that understanding these early days is crucial for even grasping how blockchain technology has covered and has involved and where it might go into the future. The next slide. Now, let me tell you about what I consider one of the most significant evolutionary leaps in blockchain technology, the development of Ethereum. And this is where the story is really exciting. So let me introduce you to Vitalik Buterin, a remarkable young developer who saw beyond blockchain's limitations. And what is really interesting here about Buterin's approach is how he recognized that blockchain could be so much more than just a payment system. So, because from this perspective, this was a crucial insight that changed everything. So, in 2013, Buterin began developing Ethereum as a new type of public blockchain. And what it made it revolutionary, and I wanted to really understand this, was its added functionality, I would say. While Bitcoin was essentially a digital currency, but on the other hand, Ethereum was designed to be a platform for building decentralized applications. And when Ethereum officially launched in 2015, so it marked the beginning of what I call the smart contract era. So let me put this in perspectives, because suddenly we had a blockchain that could handle an enormous number of transactions per day and support both decentralized applications and smart contracts as well. I have really found that Ethereum emergence represents a crucial turning point here, because it demonstrated that blockchain technology could be used for virtually any type of digital interaction, not just financial transactions. And this is why I consider it's the second major phase in blockchain evolution. So now let me share with you what I see the most exciting phase of blockchain evolution, which is the explosion of practical applications that began around 2018. And this phase is particularly fascinating because it shows how far we have come from the early days of Bitcoin. And in this analysis of blockchain development, China's role is particularly interesting because despite their cryptocurrency ban, as you may know, so they have remained at the forefront of blockchain innovation. For example, if you take NEO, for example, which is called usually the Ethereum of China. So I've been following its development closely, and what makes it remarkable is its position on the first open source decentralized blockchain platform in China. And one development, for example, that I find particularly exciting is the intersection of blockchain with the Internet of Things. So, and therefore, let me tell you about IoTA. So it's a perfect example of how blockchain technology is evolving to meet specific needs. So what makes IOTA cryptocurrency or token special? Why is it special? So it's, in my view, it's because of its unique approach. So because no transaction fees and distinctive verification process were designed specifically for IoT, Internet of Things ecosystems. From my perspective, as someone who's been studying this field for years, these developments represent much more than just technical innovations. So they show us how blockchain technology is maturing and finding real-world applications across different sectors. And the diversity of these new projects demonstrates something I always emphasize to my students, and that is blockchain technology has moved far beyond its cryptocurrency origins, for sure. The next slide. So now let us break down the fundamental concept of blockchain in a way that I think makes it easy to understand. In my experience, I've actually found that starting with the basics is really crucial. That is why when I explain blockchain to my students, for example, I start by emphasizing three key characteristics of it. It's digital, distributed, and decentralized. So let me explain what this means in practical terms. So you can think about blockchain as a special kind of digital ledger that exists simultaneously on computers all around the world. And what makes it special is how it handles information security, as it was said before. And looking at the structure itself, what fascinates me is how elegantly and elegant and simple and yet powerful it is. So, and the name blockchain is quite literal to me because it's exactly what it sounds like, a linear chain of blocks, and each containing transactional data organized chronologically. So I also have found that people often overcomplicated, but at its core, it's simply a way of recording information that makes it extremely difficult, if not possible, to change or hack, even because each block contains coded information about transactions, and these blocks are linked together in a specific order. And I think that it's really a new way of thinking about how we store and verify information. The next slide. So now let us explain blockchain in the simplest way possible. And you can imagine the chain of digital blocks, but not in the traditional sense of these words. But when we talk about blockchain, we are actually talking about something quite specific. What you see on the screen is a visual representation of how blockchain works over time, because you can notice how each block is connected to the next one, forming a continuous chain. And this is a fundamental to understanding blockchain technology. So when I say block, I'm referring to digital information that's stored in a public database, which we call the chain. And if you think about each block as a container holding important transactional data, so you can understand that. So it's really interesting, actually, that these blocks aren't stored in just one place, so they are dispersed across multiple computers. So if you wanted to tamper with the information in one block, so I need to change it across all computers simultaneously, which, as to me, is practically impossible. And the beauty of the system is its simplicity combined with incredible security. So because each new block shown on an orange in our diagram here in the slide can only be added to the chain after it has been verified by the network. So this creates an unbreakable sequence of information. And if you let me to give you a practical example, so please imagine written in a shared diary, which where each entry is locked and linked to all previous entries. For example, once you write something, so it can be changed without everything knowing about it. So it's essentially how blockchain works. The next slide. Now let me show the actual anatomy of the block in the blockchain. So here, this diagram illustrates exactly what we will find inside each block, and I really think you'll find it fascinating, because looking at the left side of the diagram of the picture, you can see a sequence of blocks. For example, 98, 99, 100, and so on. So each block is verified as indicated by those check marks. And this is really crucial for maintaining the chain's integrity here. So let's zoom in on the structure of a single block shown on the right. So every block here has three main components: a header, Merkle tree hash, and transaction ID list. So the header here is particularly interesting because it contains what I call the vital statistics of the block, actually, which is a version information, a nonce, which is a special number used in mining, a reference to the previous block, and timestamp. For you can think of it as the block's ID card, for example. And below that, we have the Merkle section, which is essentially a clever way of summarizing all of the transactions in the block. So because it's named after Ralph Merkle, who patented this tree structure back in 1979. Because it's brilliant, really, because it allows us to verify transactions efficiently. And at the bottom, we have a transactions ID list, which contains all of the individual transaction hashes included in the block's Merkle tree. So, and when the blockchain ledger size increases, it's because we are reading more of these blocks filed with transaction data. The next slide. Now let me walk you through the fascinating journey of how a blockchain transaction actually works. And this picture in the slide shows us the complete life cycle of a transaction from start to finish. So it all begins with the step one, as you can see, where someone initiates a transaction request from their computer. And this could be anything from sending cryptocurrency to executing a smart contract, for example. But in step two, the system creates what we call a block to represent these transactions. And yeah, if you think of it as a digital package, for example, containing all the transaction details like amount, sender, receiver, and timestamp. So that's it. And here, where it gets interesting, actually, in step three, this block isn't just stored in the one place. Instead, it's broadcast to every node in the network. And when I say node, I really mean every computer that's part of this blockchain network. So step four is crucial for security because all these nodes validate this transaction independently, and they check if you have, for example, sufficient funds, if your digital signature is valid, and if everything follows the network's rules. But if the validation is successful, then the nodes receive a reward in step five, and this is what we call the proof of work reward. So it's like getting paid for being an honest accountant in the system. And finally, in step five and six, the validated block is permanently added to the blockchain, and the transaction is marked as complete. Once it's there, it can never be altered or deleted. For example, that what makes blockchain so secure and reliable. So the next slide. Now let me explain this elegant diagram that shows how blocks in the blockchain are connected. So it's like a digital chain where each link is secured cryptographically to the next one. And if you look at how each block has two main parts, a header section at the top and the transaction section at the bottom. And this structure is consistent across all blocks in the chain. So what is interesting here is the header is sorry. So what is really interesting here is that the header of each block contains something called a hash of the previous block's header. And if you think of this hash as a unique digital fingerprint, so it might be much more understandable. For example, block 2 is has a header containing block 1's fingerprint, and block 3 contains block 2's fingerprint, and each header also contains what we call a Merkle root, because this is a clever mathematical way to summarize all the transactions in that block into a single value. So it's like having a tamper evidence seal for all the transactions. And here the blue arrow is showing the connections between blocks are crucial, because if anyone tries to alter a transaction in block 1, it would change block 1's hash, which would be then invalidated, or which will invalidate block 2nd, and so on through the chain. So this is what makes blockchain practically impossible to tamper with. So if you think finally like a stack of sealed envelopes, for example, then where each envelope contains a copy of the seal from the previous envelope. So if you try to open and to reseal any envelope, then all the subsequent seals would no longer match. The next slide. Now, let me show you a more detailed architectural view of how blockchain works. So you can see here the diagram on the right of the slide, and this diagram really illustrates both the connection of blocks and how transactions are collected within each block. So as you can see at the top, you can see here what we call connection of blocks, because each block contains a header with three key elements: the hash value of the previous block's header, a root of hash tree, and a list of transactions. And you can notice here how block seconds header contains block first hash value, for example, and block third contains block seconds hash value. And this creates our unbreakable change. And the bottom part of the diagram shows something really interesting, because it is called sometimes the collection of transactions, because you can look at how individual transactions labeled, for example, transaction 2.1 and transaction 2.2 and so on, organized into what we call a Merkle tree or a hash tree. So those H symbols and blue circles here represent hash functions, actually, because you can consider them as one-way mathematical functions that take transaction data and convert it into the fixed size string of characters. It's like creating a unique fingerprint for each piece of data. And what is brilliant about this structure is how it builds up from individual transactions at the bottom through pairs of hash values and all the way to a single root hash value. So this root hash then goes into the block header, effectively summarizing all transactions in the block. So if anyone tried to tamper with even a single transaction, so it would change all the hash values above it, ultimately changing the root hash and breaking the chain, because this is what makes blockchain a Fort Knox, in other words, of I'll say data security, as I like to say. The next slide. And now let me explain three fundamental concepts that make blockchain transactions so secure and trustworthy. And these elements work together to create what I consider one of the most robust transaction systems ever developed. First, let's talk about decentralized transactions. And what makes these special is that we don't need a bank or any third party to mediate our transactions in this case. And instead, member nodes in the network follow what we call a consensus protocol. You can think of it as a set of rules that anyone agrees to follow to validate transactions. And the second fascinating aspect is what we call irreversible transactions. Because once a transaction, that means that once a transaction is authenticated by the network and added to the blockchain, so it's there forever. It's like written in a permanent link. For example, you can't erase it or alter it even. So this is crucial for maintaining the integrity of the entire system. And third pillar is hash functions, because which I find particularly elegant, because every transaction on the blockchain relies heavily on these mathematical functions that create unique digital fingerprints. And these hash values are essential for linking blocks together and ensuring the data hasn't been tampered with. So you can consider this. In traditional banking, you trust the bank to keep accurate records. So, but in blockchain, otherwise, you are trusting mathematics and cryptography instead. So, and I personally find the shift from institutional trust to mathematical trust really revolutionary. So, what's remarkable about this system is that it's self-validating, because there is no need uh, to externally verify all of the things, because the integrity is built into the very structure of the blockchain through these three elements working in harmony. The next slide. Now, let me expand on the different types of nodes by walking you through the hierarchical diagram. So, because it's a fascinating visualization of how nodes are organized on a blockchain network. So, for example, if we start from the left, we have two main categories, which are full nodes and lightweight nodes, so which I mentioned earlier. But if we dive deeper into the how these branches develop, so we can understand it better. So for example, on the full nodes, we have two specialized types. For example, front nodes and archival nodes. So front nodes save space but only keep in recent transactions history, while archival nodes maintain the complete blockchain history, and they are like our digital historians, for example. So what is particularly interesting here is how the archival nodes branch um, into four distinct types. For example, master nodes, mining nodes, staking nodes, and authority nodes. And each of them has a specific role in maintaining the network's integrity. So, mining nodes, for example, are the workhorses of proof-of-work systems like Bitcoin, and they compete to solve complex mathematical puzzles to validate transactions. And staking nodes, for example, on the other hand, are used in proof-of-stake systems where they validate transactions based on the number of tokens they hold. So this diverse ecosystem of nodes ensure that our blockchain network remains both decentralized and secure, and each type of node contributes uniquely to the network's overall health and functionality. So let us explore one of the most fascinating aspects of blockchain technology, which is the consensus mechanism. So this image here in the slide on the left or right on the slide perfectly illustrates how network participants come together to validate transactions. And what you are seeing here is a visual representation of how consensus works in a blockchain network, for example, because you can notice the hexagon in the center that represents a transaction or block that needs to be verified, and the computers around it are nodes in the network. And I particularly want to draw your attention to the green check marks on some nodes, for example, because these indicate nodes that have also verified and agreed on the validity of the transaction. And the gray checkmates, check marks, represent nodes that are still in the process of verification. So this what makes blockchain so revolutionary. Instead of having a single authority making decisions, we have multiple independent nodes and that must reach agreement, for example. So you can think about it like a digital democracy where every node gets a vote. And one of the most interesting aspects is that any user can become a full node in this peer-to-peer network. So because by doing so, they gain the ability to participate in the consensus process. But however, this also raises more interesting challenges, which I will discuss in our next slide. So, but in my experience, finally, this distributed consensus mechanism is what makes blockchain nearly impossible to manipulate, I would say, because unless the majority of nodes collude, so which we will discuss when we talk about 51% attacks, so then the network remains secure and trustworthy. And the next slide. Now let us explain one of the most significant security threats to blockchain networks, what we call a 51% attack. Because, for example, this diagram illustrates how it works, and it's something every blockchain professional needs to understand, actually. Look at the top of the chain on the diagram, and this represents the legitimate blockchain where honest miners, for example, shown with the construction element icon. So I add in and broadcasting blocks openly. And this is how the system is supported to work. But however, notice the bottom chain within with a figure wearing sunglasses, for example. This represents an attacker, and what they are doing is creating their own private chain of blocks without broadcasting them to the network. So it's like they're reading their own secret ledger. And here is where it gets concerning, actually, because if an entity controls more than 51% of the network's mining power, they could potentially force the network to accept their private chain as the legitimate one. So this would effectively allow them to rewrite, for example, transaction history. And it is really particularly dangerous is that once a group controls more than half of the nodes, for example, they can change consensus rules as they see it, for example, as to them. And this could lead to what we call a monopoly situation, which is exactly what blockchain was designed to prevent. And this vulnerability is why maintaining a truly decentralized network is crucial. So because in my experience, for example, the best defense against 51% attacks is having a large, I don't know, diverse network or even independent miners and validators, for example. Next slide. So now let me introduce you to the first and most well-known type of blockchain architecture, which is the public blockchain. So it's what most people think of when they hear about the blockchain technology. But a public blockchain, in other words, is, as the name suggests, is completely open and transparent. And you can imagine a giant digital ledger, for example, that anyone in the world can not only see, but also participate in. It's like a public park open to everyone. And what makes public blockchains fascinating is that they allow any user on the internet to verify and modify even transaction blocks. And this level of openness creates an unprecedented degree of transparency and in overall digital transactions. So, and let me give you another example. For example, Bitcoin, which pioneered blockchain technology, is a public blockchain. In other words, and Ethereum, for example, which introduced smart contracts, is another prime example. Because there is a Dash, for example, is yet another well-known public blockchain. So the beauty of this system is its complete decentralization. Because there is no central authority control and access or permissions, and everyone has equal rights to view, to verify, and to participate in the network. However, this openness comes with the trade-offs in terms of transaction speed and energy consumption, which we'll discuss when we compare it to other types of blockchains. The next slide. Now let us explore private blockchains, which represent a fascinating evolution in blockchain technology. So they operate quite differently from the public blockchains we have just discussed. You can think of a private blockchain as a gated community within a single organization. For example, unlike public blockchains where anyone can participate, on the other hand, private blockchains are much more selective about who gets to do what. So what I find here particularly interesting about private blockchains is their hybrid nature. So because while the content of blocks can still be viewed by anyone on the internet, maintaining some level of transparency. For example, the ability to manipulate or add to this block is strictly controlled, comparing to the public blockchain, for example. So, and now let me emphasize this point. In a private blockchain, only specific individuals within the organization have the permissions necessary to verify transactions and you add new blocks, for example, and this makes them ideal for businesses that need both security and control. And for example, platforms like multi-chain and Blockstack may be excellent examples of private blockchain implementations. And because these solutions allow organizations to maintain control while still leveraging the benefits of the blockchain technology. And so, in my experience, by the way, working in my experience of working with the organizations and within which private blockchains often provide the perfect balance between the transparency of blockchain technology and the control requirements of traditional business operations. So the next slide. Now, let me explain what makes consortium blockchains unique and why they are particularly valuable for organizations. Let's think that unlike public or private blockchains, consortium blockchains operate under a different model of control and access. And in my experience working with the various blockchain implementations, so I can say that I found that consortium blockchain offer an excellent middle ground. In other words, so you can think of them as a hybrid solution. For example, they are neither completely open like Bitcoin or nor fully closed like private corporate blockchains. So it's something in the middle. And they are very special, and their special features is that only a pre-selected group of organizations or individuals can verify and add transaction blocks into them. So I like to give you the example of, for example, of such a blockchain network as Ripple. because it's one of the most well-known consortium blockchains, along with the R3 and Hyperledger, for example. You may have heard about that. So this ledger in a consortium blockchain can be configured to be either open for everyone to view or restricted to specific groups only. And this flexibility is particularly valuable for industries where multiple organizations need to collaborate while maintaining higher security standards. So, and for example, in my consulting work, so I've seen many organizations across different sectors who selected consortium blockchains specifically for their enhanced security features. So, and when somebody asked me, for example, about real-world applications of this kind of blockchains, I often point to financial institutions that need to share data with their partners, for example, while maintaining strict control over who can validate transactions, because this balance between collaboration and control is what makes consortium blockchains particularly attractive for enterprise use. So let's turn on to the next slide. Now I want to help you understand the fundamental concept of blockchain, Bitcoin blockchain, and as it's really crucial for grasping how modern cryptocurrency system work. So now let me start by saying that before we dive into the technical aspects of how blockchain and Bitcoin interact. First of all, it's essential to understand the basic precepts of Bitcoin itself, because I often find that students, for example, get confused between Bitcoin and blockchain, but they are not exactly the same thing, as to me. So you can think of Bitcoin as a specific application of blockchain technology. So when I explain, for example, this to my industry colleagues or to someone, I usually describe Bitcoin as a form of electronic cash, which is a cryptocurrency that functions similarly to traditional currency units, but with some unique characteristics. So, and in my years, for example, of studying digital currencies, I have observed actually that Bitcoin represents one of the most successful implementations of blockchain technology, because what makes it particularly interesting is how it combines several technological innovations to create a completely new form of money. So here, in continuation of this, I would like to emphasize that while Bitcoin might seem complex at first, its underlying principles are actually quite elegant. So, because as we progress through the course, you will see how Bitcoin uses blockchain technology to solve problems that had stumped digital currency developers for decades. And the relationship between Bitcoin and blockchain is one of the most fascinating aspects of modern financial technology, and understanding this is really crucial. So now let us walk you through how the Bitcoin blockchain actually works in practice. So here you can see the diagram on the right of the slide, and it is particularly helpful in explaining the system's architecture. So if you look at this illustration, you can see the key components of the Bitcoin ecosystem. So let me break it down for you. At the top, we have the block miner, for example, who plays a crucial role in validating transactions. And on the left and right, we have senders and receivers. These are the users conducting transactions. And what is interesting here about this system is its peer-to-peer nature. So, because you can notice how there is no central authority controlling the process here, but instead is, as shown on the center of this diagram, of this picture, we have a distributed ledger. So that is our blockchain, which connects all the participants here. And I'm really often asked about being asked about the role of traditional financial institutions here. So as you can see in the lower part of the diagram, while banks and exchangers are part of the ecosystem, but they are not controlling the transaction process. So, but otherwise, they are interfacing with the blockchain network just like other participants. So, and the money transfer services shown on the bottom here represent the practical application layer where Bitcoin can meet traditional finance, for example. And this is where, in my view, the real innovation of blockchain technology becomes apparent, because it creates a trustless system where transactions can be verified and recorded without requiring a central authority. So, and now I would stress your attention that this is a simplified model, but it captures the essential elements of how Bitcoin's blockchain operates in practice. And the beauty of the system, for sure, is its ability to maintain consensus across a distributed network while ensuring security and transparency. So the next slide. Now, let me draw your attention to a crucial distinction that I believe is often overlooked in the blockchain discussions. And when we compare Bitcoin's blockchain to business-oriented blockchains, for example, there might be three fundamental differences that I want to highlight. Thus, from my experience working with both cryptocurrency and enterprise blockchain solutions, so I have really observed that these distinctions significantly impact how each type of blockchain is implemented and used. Because many of my colleagues, for example, in the industry initially struggle to understand why we couldn't simply apply Bitcoin blockchain, for example, and its model directly to the business applications. And what is interesting here is what I will explain in more detail in the following slides. And that is how these differences shape the way transactions are processed. How identity managed, for example, and how consensus is reached or achieved. And these three characteristics from the foundation of why business often need a different approach to blockchain implementation, I think it's much more important that Bitcoin offers. So, and what is another interesting, fascinating thing here is how these differences emerged naturally as blockchain technology evolved from its cryptocurrency origins to broader business applications. And for example, in my work, I think understanding these distinctions has been crucial for helping organizations choose the right blockchain architecture for the specific needs. So let's examine each of these characteristics in default And let us start with the first major difference in the next slide. So, and I really find it illuminating how its characteristics, I would say, address specific business requirements that may differ from Bitcoin's original purpose. So, the next slide. Now, let me explain one of the key differences between Bitcoin's blockchain and business-oriented blockchains, which is their approach to assets. This is really something I find particularly fascinating in my research and practical work with blockchain implementations. When most people think about blockchain, they immediately think of cryptocurrency. But however, I want to emphasize that blockchain technology has evolved far beyond just digital currencies. Because in my experience working with various industries, I really seen blockchain being applied to an incredibly diverse range of assets. And what is really exciting here about the business blockchains is their versatility, I would say. Unlike, for example, Bitcoin's blockchain, which was specifically designed for cryptocurrency transactions, I would say that business blockchains can handle virtually any type of asset, and you can imagine. So, and I have seen for sure them used for everything from supply chain management and to real estate titles, from even intellectual property rights to, I don't know, energy trading. So, that's particularly interesting, I would say. And what I often tell to my students, for example, is that this broader application of blockchain technology actually opens up more possibilities than the original cryptocurrency use case, for example. So when we move beyond just thinking about digital currency, so we can start to see how blockchain can revolutionize almost any industry that deals with the asset tracking and asset transfer. And so I have also observed actually that this flexibility in handling different types of assets is often what makes blockchain technology so attractive to business. So and it's not just about moving money anymore. It's about, I would say, it's about creating new ways to track, to transfer, and to even verify ownership of any kind of asset. So the next slide. Now, let me explain another crucial distinction between Bitcoin's blockchain and business blockchain. So, which is, I would say, their approach to identity. So, this is something that I believe fundamentally shapes how these systems operate in practice. And I usually emphasize actually that one of its core features I talk about, I tell you about the blockchain, Bitcoin blockchain. So one of its core features is anonymity, as you can say. So that's what makes it so unique. For example, users can conduct transactions without revealing their real identities. And however, in my work with businesses, I have found that this approach simply doesn't align with the real world business requirements. So now let me break this down into three key points. First, Bitcoin's blockchain thrives on anonymity. So that is a fundamental part of its design. But, and this is really crucial, businesses operate in a regulated environment where, for example, the concept know your customer or KYC and anti-money laundering AML concept in terms of compliance are I would say, non-negotiable requirements. So here, what I find particularly interesting here is that business blockchains actually need to be designed with these compliance requirements in mind. And I would say that would be started from the ground up. And in my experience, also consulting, for example, with the financial institutions, I've really seen how this must maintain a delicate balance between transparency and privacy as well. And finally, I would like to emphasize that this isn't just about following regulations. So because it's more about creating systems that work in the real business world. Because when I discuss it, for example, we often note how this identity-centric approach actually enables more, I will say, sophisticated business applications while maintaining necessary compliance standards. The next slide. So here, let me explain the third major distinction between Bitcoin's blockchain and business blockchains, which is their consensus mechanism. So now this is, as to my opinion, this is one of the most significant architectural differences I've encountered in my research and practical work. And in, for example, in business blockchains, we use what I call selective endorsement for achieving consensus. So now let me explain what this means with a practical example that I often share with my students, for example. And for example, you can think about when you transfer money to a third party, for example, your transaction is verified by your bank, and um, the recipient's bank and may verify it as well. And another verifying party may be possibly a payment provider. So there are several parties to verify your each of your transactions. So and this is some kind of selective endorsement in action. So and what is fascinating about this approach is how it differs from the Bitcoin's proof of work system. For example, in my experience, I've seen how businesses can achieve much higher efficiency only by allowing specific or trusted parties to verify transactions rather than requiring network-wide consensus. So, and what makes this so powerful is that businesses can control exactly who verifies their transactions. In other words, and this not only makes the process more efficient, but also aligns with existing business relationships and regulatory requirements. So I can say that I have implemented such systems where specific industry partners act as validators, for example, and creating a perfect balance between trust and control. So, and here, here is a fundamental, as to me, here is a fundamental shift from Bitcoin's approach, because while Bitcoin needs proof of work to consensus to maintain trust in a relationship, to create more efficient consensus. Make the next slide. And now let me walk you through the process of blockchain mining. So, and this process, I would say, this is essential for securing and verifying Bitcoin transactions, because on this diagram on the slide, it is perfectly illustrated the complete mining cycle. So in many years of studying blockchain technologies, I have really found that mining is often misunderstood, actually, because to show that, let me break down this process step by step and following simultaneously the areas in our diagram. So it starts with what you see on the top left, transaction being initiated on someone's computer. So you can think of this as someone wanting to send Bitcoin to another person. So what happens next is particularly interesting, because the transaction details are broadcast to miners across the global network. And that is presented by the globe icon in the diagram, you can see. And I often tell anyone to imagine this as a worldwide announcement saying, for example, hey, there's a I don't know, there's a transaction that needs to be verified. So, and the miners then compute to complete the verification process, which is shown by the pickaxe, I would say, pickaxe symbol on this picture. So what is very interesting in this part about this part is that miners are essentially solving complex mathematical puzzles. So when a miner succeeds, they not only verify the transaction but also get rewarded with the new bitcoins. And if you look at the bottom of the diagram, for example, you can see how the verified transaction gets added to the blockchain, creating that permanent, unalterable record. And finally, the transaction is marked as complete and represented by the handshake icon here. So what makes this system particularly brilliant, I would say, in my experience, is how it creates a self-sustaining cycle where miners are incentivized, I would say, to maintain the network security through the reward system. The next slide. So now let us consider or dive deeper into the different types of mining that exist in the blockchain ecosystem. So this is really a topic I'm particularly passionate about, because it shows how blockchain technology has really evolved to accommodate different levels of participation. So, and in my experience, I found that, for example, many people are surprised to learn that mining isn't just one uniform process. So, and the complexity of mining operations mean, in other words, that a regular desktop or PC simply isn't sufficient anymore. So, because this is something I learned firsthand when I first started, for example, researching blockchain technology. And what is interesting is how mining, I would say, how mining has developed into a sophisticated operation requiring specialized hardware and software as well. When I deal with the companies interested in mining operations, for example, I always emphasize that the importance of having the right setup for their specific mining goals is a key. So now let me share something from my practical experience with you, and that is each type of mining requires a unique combination of equipment and approach. because it's really crucial to understand that what works for one type of mining might not work for another. So, and I have seen actually many newcomers make the mistake of, I would say, of trying to mine with inadequate resources. So, and in the next slide, I'll break down the three main categories of mining that have emerged in the blockchain ecosystem. And each of these categories has its own advantages and challenges, and understanding this difference is crucial for anyone considering getting involved, I would say, in the mining operations. The next slide. So now let me walk you through the three main categories of mining that we see in the blockchain ecosystem today. So these images perfectly illustrate the distinct approaches to mining that has evolved over time. So first, let's look at the individual mining shown on the left. So I remember when this was the primary way people mined Bitcoin, for example, using just specialized hardware called ASICs, ASIC, like the one picture, for example, to the left. And so for example, I watched this transaction from CPU mining to these dedicated devices, for example. But however, I should mention that individual mining has become actually increasingly challenging due to the growing computational requirements. And in the middle, we see pool mining, which is represented by the creative image of miners working together in a Bitcoin. So this is what I consider one of the most innovative developments in mining, actually. And from my perspective, I think analyzing mining operations, so I've seen actually how pool mining allows individuals to combine their resources and have rewards, for example, making mining more accessible to average participants. And finally, on the right here, you can see so-called cloud mining. So those massive data centers filled with the mining equipment, for example, and I have had actually the opportunity to visit several of these facilities, and I can tell you that they are impressive operations. So, and this approach actually allows people to mine cryptocurrencies without owning or maintaining any hardware themselves. And what is interesting here about these three categories is how they represent the evolution of mining from a hobby activity to sophisticated industrial operation. And each model here serves different needs and has its own risk-reward profile, which I will be happy to discuss in more detail if you are interested. So now we have come up to the break. And if you don't mind, let's break for 10 minutes. So we are getting back in 52 minutes. Okay, we go on. Do you hear me well? Do you see the presentation?
Yes, Professor. Can see the presentation.
Yeah,
Yes,
great.
Professor.
Yeah, thank you very much. So do you have any questions so far?
No, for now, no.
Okay. So anyway, you can write it down in the chat. So please do not hesitate to. And therefore, we continue. So the next slide, just a second. Yeah, that's it. So now let me introduce you to the Ethereum, the blockchain platform I said you before, invented by one of the founders of which was Vitalik Buterin. So I really consider Ethereum as one of the most revolutionary developments in blockchain technology since I would say Bitcoin itself. And this platform was conceptualized by a brilliant young developer named Vitalik Buterin in November 2013. I actually have found that Ethereum represents a quantum leap forward in what blockchain technology can do because while Bitcoin was designed primarily as a digital ambitious, think of it as a global computer that can run decentralized applications. Now let me explain something that I find particularly fascinating about Ethereum. Its native cryptocurrency is called Ether. But unlike Bitcoin, Ether isn't just designed for financial transactions. And in my discussions with the developers, I often emphasize how Ether serves as the fuel that powers the entire Ethereum ecosystem. What makes Ethereum truly special, and what I always emphasize to my students, is that as to my opinion, it introduced the concept of programmable blockchain. Through my own work with various blockchain projects, I have really seen how this capability has opened up entirely new possibilities that weren't feasible with the Bitcoin alone. But this innovation has led to what I believe is one of the most vibrant developer communities in the blockchain space. And the platform's flexibility and programmability have made it the foundation for countless innovative projects from, I would say, decentralized finance to digital art markets. The next slide. Now let me explain the three fundamental characteristics that make Ethereum such a groundbreaking blockchain platform. From my years of working, I can tell you that Ethereum's architecture is truly unique. First, let me emphasize its open source nature. In my experience, for example, I've seen how this openness has been crucial for innovation in many ways. And Ethereum is not just a blockchain, it's a complete distributed computing platform and operating system as well. And what excites me most of all about this is its smart contract functionality. I believe that it has revolutionized how we think about the blockchain applications even. And secondly, let's talk about distributed applications, or DApps, so-called, as we call them such a way in the industry. What is remarkable about Ethereum's architecture is that these applications run exactly as programmed, without any possibility of downtime, fraud, or interference from third parties, for example. And I worked with many companies implementing DApps, for example, and this reliability is absolutely crucial for their operations. And finally, and this is something I'm particularly passionate about, is that Ethereum's Turing-complete programming language. And I explain this, what this means to developers is that they can write virtually any kind of program to run on the blockchain. It's like giving developers a complete toolkit to build whatever they can imagine. And in my view, finally, these three characteristics together make Ethereum much more than just another blockchain. So, because in my opinion, it's a platform for the future of decentralized computing. The next slide. Now let me explain why Ethereum is more than just a cryptocurrency platform. For example, unlike Bitcoin, which primary focus on financial transactions, as I said before, Ethereum serves as much broader purpose in the blockchain ecosystem. So first, I want to emphasize that Ether, which is Ethereum's native cryptocurrency, plays a crucial role in the platform's operation. For example, when you are using the Ethereum network, Ether is used to compensate the mining nodes for their computational work. And you can think of it as paying for the processing power that keeps the network running. And what makes Ethereum truly special is its versatility, I would say, because I often tell that if Bitcoin is like a specialized tool, then Ethereum is more like a complete workshop. So you can build practically anything on it. The platform, for example, supports a wide range of applications beyond simple fund transfers. And I have also seen how Ethereum has revolutionized the way we think about decentralized applications as well. So, for example, you can create smart contracts, build decentralized autonomous organizations, or we call them DAOs, or even launch your own tokens. And all of this is being made on the Ethereum platform. I really believe this flexibility and broader applicability is what makes, I would say, Ethereum such a powerful force in the blockchain space. In fact, many of the innovative blockchain projects where we see today are built on the Ethereum's infrastructure. The next slide. So now I'd like to introduce you to the concept in Ethereum platform called gas. So so I often compare gas to the fuel that powers, for example, your car, and without it you are not going anywhere on the Ethereum network. So let me break down how gas works in practice, for example. Um, First, when miners process transactions or execute, for example, smart contracts on Ethereum, they need to be compensated for their computational work. And this is where gas comes in, because it's essentially a fee-paying system that serves multiple purposes. And first, gas acts as a spam prevention mechanism. For example, if every transaction or smart contracts execution required a fee, it becomes economically unfeasible for malicious actors to flood the networks with meaningless transactions. And I've really seen how effective this is in maintaining network health. And what's particularly clever about the gas system is how it allocates resources. For example, every operation on Ethereum, whether it's a simple transfer or a complex smart contracts execution, it requires a specific amount of gas. And the more complex the operation, the more gas it needs, for example. And here is an important point I want you to remember. For example, that is miners are incentivized to include transactions with higher gas prices in their blocks first. And it's a beautiful example of how economic incentives can be used to maintain network efficiency, for example. And otherwise, when you're developing applications on Ethereum, understanding gas optimization is really becomes crucial for cost-effective operations. The next slide. And now let me share. Sorry. Let me share with you what I find most exciting about Ethereum's potential applications. For example, I've been following its development since the early days, and the possibilities continue to amaze me, really. First and foremost, Ethereum is revolutionizing how we think about decentralization. And for example, I've seen firsthand how Ethereum can decentralize thousands of processes across different industries. You can think about, for example, traditional banking services, insurance, or even supply chain management, for example, and all of this can be transformed through Ethereum's blockchain technology. So, and Ethereum is changing in other words, the landscape of financial services. Take loans, for example. Traditionally, you'd need multiple intermediaries, lots of paperwork, and days or weeks of processing time, for example. But with the Ethereum-based solutions, these processes can be automated and made more efficient and significantly more secure. So, and here I can emphasize your attention on this point, because if we were to decentralize all centralized services using Ethereum, then virtually every aspect of our daily lives could become more secure and more efficient. And I'm talking about everything from voting systems to property records, from identity verification to supply chain tracking even. And the beauty of Ethereum lies in its programmability and flexibility, because it's as to me, it's not just a platform, it's an entire ecosystem that's constantly evolving and improving. So the next slide. And now I would like to introduce you to one of the most revolutionary concepts in blockchain technology, or which is smart contracts. As I said it before. The story begins with the brilliant computer scientist named Nick Szabo. Maybe you've heard about him. And this guy actually, while pondering about Bitcoin blockchain security, really came up with this innovative idea. So now let me paint a picture for you. Let us imagine traditional contracts. So they require intermediaries, trust between parties, and often complex enforcement mechanisms. And now, what Szabo envisioned was different. For example, he thought about creating software-based protocols that could automatically facilitate, verify, and enforce even contract terms. And I've actually come to appreciate just how groundbreaking this concept was actually during my experience. Because you have to think about it, a contract that executes itself without any need for intermediaries or manual oversight, for example. And that's exactly what smart contracts do. And I really find it fascinating how Szabo's original concept has evolved into what we see today in blockchain platforms, for example, like Ethereum. And these smart contracts are now even revolutionizing everything from financial services to supply chain management. They are because they are essentially computer programs that automatically execute when specific conditions are met. So, and finally, the beauty of smart contracts lies in their simplicity and reliability, because once deployed on the blockchain, they can operate exactly as programmed. No exceptions, no human interventions needed. So the next slide. So please just give me a couple of half of the minute. So we go on. Now let's talk about the how smart contracts actually work in practice. So I usually use this diagram you can see on the slide just to explain the process, because it perfectly illustrates the four key stages of smart contracts life cycle. So it all starts with what we call a predefined contract. So this is where all parties involved agree to specific terms and conditions. And in my experience, this is really crucial, because once these terms are coded into the blockchain, they cannot be altered. For example, you can think of it as carving your agreement in stone, so it's permanent and transparent. And the second stage involves events. So I like to think really of this as triggers. And for example, if we are dealing with a payment contract, for example, an event might be or might be reaching a specific date or receiving a particular amount of cryptocurrency. So these events are what set the smart contract in motion, in other words. And next comes the execution phase. And here, what I find really interesting, once the predefined conditions are met, so the contract executes automatically. So there is no need for mutual intervention, no paperwork, no delays, for example, and it's all handled by the blockchain network. And finally, we reach the settlement stage. So because all agreed upon transactions or actions are completed quickly and efficiently. And what is particularly impressive is that this entire process happens without any intermediaries and simultaneously reducing both time and cost. So, and finally, I always emphasize that this automation and efficiency is what makes smart contracts truly revolutionary in the business world. The next slide. So this slide illustrates that what we call the Byzantine generals problem. So, and it relates directly to the blockchain technology. Honestly, I find it one of the most fascinating aspects of how smart contracts maintain security, for example. And let me explain why this is so crucial. So if you look at these two scenarios in the image, on the left, we see a perfectly coordinated attack where all participants are working together. So this represents how a blockchain should function ideally. But on the right, we see what happens when there are traitors in the system, for example, and this represents potential bad actors in the blockchain network. And the brilliant solution here to this problem comes in the form of Byzantine fault and Byzantine, I would say, problem-tolerant algorithms. So, now, for example, I've seen how these algorithms effectively ensure that smart contracts continue to function correctly, even when some nodes in the network are trying to act maliciously or simply failing. And what makes this even more powerful is the implementation of Turing complete programming languages, because these languages allow us to create sophisticated smart contracts that can handle complex logic while maintaining security. So, and I always tell that this combination like Byzantine fault tolerance and Turing completeness is what makes smart contracts truly revolutionary. So you can think of it as having a system, for example, that can only detect and ignore bad actors, but also execute complex operations with absolute precision and reliability. The next slide. Now let's talk about this practical example on how smart contracts work in real estate transactions. For example, I think that this illustration is particularly helpful because it shows the real world application of what's been discussing. So if you look at the top of the diagram, we have a seller and a buyer of a, for example, of a house. And in traditional real estate, this process would involve multiple intermediaries and plenty of paperwork and significant time delays. But with the smart contracts, it's remarkably different. So notice, you can notice that the central exchange mechanism exists here. And what is very interesting as to me is how the smart contract automatically handles the matching of buyer and seller sides, and how it manages the asset distribution. Because the contract here acts as an automated escrow service, if you will. But at the bottom, you can see two crucial elements: the digitized land deed and digitized currency. And the land deed is tokenized, for example, meaning it's converted into a digital asset. And while the payment is made in cryptocurrency, typically, for example, Bitcoin or Ethereum. And the smart contract ensures that both the deed transfer and payment happen simultaneously. And what is great about the system is that it's automated and undisputed. For example, the clearing and settlement process happens without human intervention here. And once it's recorded on the blockchain, the ownership is immutable and transparent. This is why I believe smart contracts are revolutionizing not just real estate, but any industry that relies on contracts and trust. So the next slide. And now let me share with you the 6 key benefits that make smart contracts truly revolutionary in today's digital economy. So because I've seen these advantages transform business firsthand. Starting with the autonomy. This is a game changer, actually, because unlike traditional contracts, smart contracts operate without intermediaries. And in my experience, this elimination of middleman not only speeds up process, but also reduces the potential for manipulation or for human error. And the transparency aspect is equally crucial, because I always tell my students that this is like having a glass house for your agreements, where every party can see exactly what they are getting into. And here, all terms and conditions are fully visible to relevant parties, which dramatically reduces disputes. And here, looking at the backup and accuracy, so this feature particularly really excites me. because every transaction detail is recorded multiple times on the blockchain, making it virtually impossible to lose information. And because it's automated, we eliminate those pesky human errors that plague manual form filling, for example. And the trust element is fascinating as well, because your documents are encrypted in a shared ledger. And you can think of it as having your agreement stored in the world's most secure digital vault, for example. And finally, let's talk about savings. So in my work, I've really seen companies reduce costs significantly by eliminating intermediaries, and this benefit alone has made many organizations switch to smart contracts. So, and I would say finally that these benefits combine to create what I believe is the future of the contract management and execution. The next slide. So now let me highlight two fundamental aspects that make smart contracts a game changer in modern business transactions. So first, let's talk about efficiency and accuracy. What is very remarkable as to me about smart contracts is their automated execution. So you see that once the predefined conditions are met, the contract executes immediately. No delays, no paperwork, no manual processing. So in my practice, I've seen this reduced transaction timely from weeks to mere minutes even. So it's like having a tireless, perfect employee who never makes mistakes and works 24/7. And the second key aspect is truthfulness and transparency. And this is where blockchain technology really shines, because every single transaction is encrypted and shared across the network. Yeah. And I often um, tell everybody to think of it like having thousands of notaries all validating your documents simultaneously. So what makes it particularly powerful is that once a transaction is recorded, so it's impossible to alter it without everyone knowing. And I can tell you finally that this combination of automation and transparency has really revolutionized how business handle contracts. The next slide. Now, let me explain two crucial technical features that make smart contracts so secure and reliable. So, in my working, for example, with the blockchain technology, I think these aspects have consistently proven to be the backbone of successful implementations. And first, let's talk about encryption. So first of all, I want you to imagine your most sensitive business document, for example. And now in a smart contract, this document isn't just encrypted once, so it's encrypted using sophisticated cryptographic algorithms and distributed across the entire blockchain network. And this level of scrutiny actually and its security is virtually in I would say impenetrable. So it's like having your document locked in thousands of high security vaults simultaneously. And the second crucial feature is that blockchain technology itself. So I often compare this to the chain of digital DNA. And each transaction, each piece of information is not just recorded, but is intrinsically linked to every other transaction before and after it. So this interconnected nature creates what we call an immutable record. So meaning that it's practically impossible to tamper with. So, and I usually emphasize actually how these two features work together, because the encryption protects the content, while the blockchain structure ensures the integrity of the, I would say, entire system, of the overall system. And it's this combination that makes smart contracts not just secure, but truly revolutionary for business operation. The next slide. So, and now I would like to discuss some critical challenges we face when implementing smart contracts on blockchain. So let's now highlight three main issues that, for example, every developer and business needs to be aware of. So first, let's talk about modifications. One of the most significant challenges is that altering a smart contract process is extremely time consuming, and in some cases, it's practically impossible. So, because this is due to the immutable nature of the blockchain technology. Because once deployed, you can't simply edit the code like you would, for example, with the traditional software. But another challenge that might surprise you, for example, in the involvement is the involvement of third parties. Because while smart contracts aim to minimize intermediaries, we can't completely eliminate them in practice. And there are situations where contract terms aren't met as agreed, and we need external verification or arbitration. So, and I've really seen this happen in several real-world implementations. And finally, there is the issue of vague contract terms. For example, traditional contracts often contain ambitious language that humans can interpret based on the context and common sense. But however, smart contracts operate on strict logic and can't handle such ambiguity. So they need, in other words, explicit, precise terms to function correctly. And this really creates a significant challenge when translating traditional legal agreements into smart contract codes. And I would say that in my experience, for example, these challenges often catch developers and business off guard, I would say. And that is why it is crucial to understand and plan uh, them from the beginning and any smart contract implementation. The next slide. So now that we have covered the challenges, let me share my perspective on where smart contracts are headed. So I'm particularly excited about their development potential and about their future applications. So looking at the current trends, I can tell you that smart contracts are poised to revolutionize complex commercial transactions for sure. And we've seen, for example, innovative applications across various industries. And I really believe this is just the beginning. And for example, from my experience, I can say that we've only scratched the surface of what's possible. So, and one area that, for example, particularly interests me is how smart contracts are transforming incentive and reward structures in contracts. For example, you can think about traditional business agreements, and for example, they are often static and require manual enforcement. But with the smart contracts, we can create dynamic and self-executing reward systems that automatically adjust based on the performance metrics. And what's truly revolutionary is how smart contracts are facilitating the transition of traditional contracts into digital platforms. And I have really worked with several companies that have successfully digitized their contract processes, and the efficiency gains are remarkable, actually. And the ability to automate, for example, contract execution while maintaining security and transparency here is a game changer. And here, what is another interesting thing is there are still so many unexplored possibilities actually here in this sphere, because as blockchain technology continues to evolve, we'll see smart contracts being applied in ways we haven't even imagined yet. So I believe we are at the cusp of a major transformation in how businesses handle agreements and transactions. So now let me walk you through the 4 key benefits of blockchain technology that make it such a transformative innovation. And I've seen these advantages, for example, firsthand in numerous implementations. First, let's talk about time savings, because it's remarkable how blockchain has revolutionized transaction speeds. For example, this is particularly crucial in today's fast-paced financial world. And the second benefit is, and this is something that often surprises, for example, me, is cost reduction. So because by eliminating intermediaries and overhead costs, blockchain significantly reduces operational expenses. And so I've really worked with the several companies that have seen dramatic cost savings after implementing blockchain solutions. And now security is a major concern in our digital age, for sure. And this is where blockchain really shines, because the third benefit is the risk reduction. So the technology has an inherent structure which makes it extremely difficult to tamper with or commit fraud, for example. And I can tell you that the cryptographic principles underlying blockchain, so they really provide an unprecedented protection against cyber crimes. And finally, and this is perhaps the most interesting benefit, that blockchain increases trust through shared process and record keeping. So, and I've observed actually how transparent, immutable records create a level of trust that was previously impossible to achieve this in traditional systems. And I think that these benefits combine to create a compelling case for blockchain adoption across even various industries. Or just a second. Okay, we go on. And now let me explain why blockchain's immutability, so-called immutability, is such a game-changing feature. So, and I think that this characteristic provides several crucial advantages, for example. And one of the most powerful aspects, and I want to emphasize this, is the consistency of results. Because once code is locked into the blockchain, so it cannot be manipulated. And if we consider the real world example, for example, in traditional banking systems, transactions can be reversed or altered, but on blockchain, on the other hand, once a transaction is recorded, it's permanent and unchangeable. And what is fascinating of this is how blockchain technology has revolutionized transactions, even because, for example, I've seen firsthand how it eliminates many of the inefficiencies that plague traditional systems, because the speed, accuracy, reliability of blockchain transactions are truly remarkable. And the enhanced security as well is a very important aspect to be, which cannot be overstated. And what is the most important thing is that blockchain is redefining digital authentication. What do I mean? So this is not just theoretical thing. So because I've seen how it enables unprecedented levels of trust and transparency in digital interactions, for example, and its ability to verify and track transactions without relying on intermediaries is, I think, is transforming how we think about digital trust. So the next slide. Sorry. Yes, and now let me share with you how blockchain is fundamentally changing the way we think about the digital authentication. So this is something I'm really passionate about, because it represents a paradigm shift in digital security. For example, blockchain provides us with the entirely new tools for authentication and authorization in the digital world, because what makes this truly revolutionary that it works without requiring traditional centralized administrators. So let me explain this and how it is significant. So in traditional systems, you typically need multiple administrators to manage access and verify identities, for example. But blockchain eliminates this need, because through its distributed nature, it creates a system where trust is built into the protocol itself rather than being dependent on any central authority. And what is interesting here is how it enables entirely new types of digital relationships, for example, because these aren't just incremental improvements, they are fundamentally new ways of establishing trust and conducting transactions in the digital space. So you can think about the implications of this. For example, every digital transactions we have today relies on some form of central authority, while blockchain technology is changing that paradigm, creating more resilient, efficient, and trustworthy systems. And here I believe this is just the beginning of the major transformation in how we handle digital authentication. The next slide. We've told about the security aspect, so I'll skip it, and so I'll skip it as well. So now let me share some important insight about the challenges and limitations of the blockchain technology. In my conversations, for example, with the IT professionals across the industry, I've really noticed a growing concern about blockchains becoming overhyped, I would say. For example, they have a point, because while I'm incredibly optimistic about blockchain's potential, so I think we need to be realistic about its current limitations. So, and let me be specific about what I mean. The versions of blockchain technology that are currently available have significant constraints. For instance, I've seen projects where blockchain was implemented simply because it was trendy, but not because it was the best solution. And this is something we need to be careful about. So, and what I've learned from my experience is that blockchain isn't always the most appropriate solution for many digital interactions. For example, sometimes traditional databases or other technologies might be more efficient and cost-effective even. And I always advise to for example, to my customers, to my clients, to carefully evaluate whether a blockchain is truly necessary for their specific tasks or not. And this doesn't mean blockchain isn't revolutionary. Indeed, because it absolutely is. But as with any emerging technology, we need to be thoughtful about where and how we apply it. Because, for example, I've seen both successful implementations and failures, and the key difference often lies in understanding these limitations and making informed decisions about when to use blockchain technology. And now let me share with you some important considerations about blockchain's role in building the digital backbone in our future internet. So at for example, this is actually something I've seen closely studying and implementing, and there are crucial aspects we need to consider here. I've really observed how digital currencies or private cryptographic keys and the underlying blockchain technology are becoming fundamental building blocks for our digital infrastructure, for example. But however, and this is something I always emphasize to people. So we need to approach this development with the careful consideration. So, and what particularly concerns me, and what I've seen firsthand in cybersecurity incidents, is that we are not the only ones advancing technologically, because, for example, hackers and malicious actors are also becoming more sophisticated, and they are developing increasingly advanced technologies and techniques to exploit vulnerables. And this is why I always stress the importance of a balanced approach. For example, while we are building these new digital systems, we must remain vigilant about security. And for example, in my experience, successful blockchain implementations require not just technological or technical expertise, but also a deep understanding of potential security threats and how to mitigate them. And trust here is essential, but it must be tempered with the caution, I would say, because as we continue to build this digital backbone, I think we need to ensure we are not just creating efficient systems, but also secure ones. So that is the next slide. And now let me address one of the biggest challenges I've encountered when teaching this kind of technology, at its inherent complexity and the often overwhelming technical jargon. So this is something I deal with regularly in both academic and professional settings. So in my experience, I've noticed actually that making cryptography mainstream is particularly challenging because while the mathematical principles behind blockchain are fascinating, they can be intimidating for many people. Because I often tell, for example, that understanding blockchain is like learning a new language. It takes time and patience. And the complexity of cryptocurrency is another significant barrier, because, for example, I frequently encounter confusion about how cryptocurrencies work and their relationship with blockchain technology. And so, if you let me be clearer, then this complexity isn't just about technical understanding. So, it's also about grasping the philosophical, we'll say, and economic principles underlying the systems. So the next one. And now let me explain one of the aspects of blockchain technology that makes it particularly resilient. And one of the most remarkable features is what we call anti-fragility. So which is the ability to become stronger in response to attacks and challenges. So you can think about it the following way. For example, when traditional systems face attacks, so they typically weaken or fail. But what is about blockchain? So it's quite the opposite. So each attempt actually helps the system identify, fortify, I would say, weak points. And I like to compare it to how our immune system becomes stronger after fighting off an infection, for example. However, and there is a catch that I would like to highlight here, because despite this incredible characteristic, many blockchain implementations aren't reaching their full potential, because the main reason might be that insufficient market exposure exists. It's like having a powerful engine, but never taking it out of the first gear. And what I particularly want to emphasize to you is that the critical importance of having a robust network of distributed nodes is really crucial here, because it's not just you have to understand, it's not just the technical requirement, it's the foundation of the blockchain strength. Even the next one. And now let's draw our attention to a crucial aspect of blockchain that often gets overlooked in technical discussions. So, which is the quality of data that goes into the system. So you can see blockchain's famous principle was saying garbage in, garbage out. And it's really practically critical for the development of the technology. And so let me take my own experience, for example, and I could say that having an immutable database is only available if the information going into it is accurate and trustworthy. So this is on the first place. And you can think about it because if you are recording an accurate data permanently, so you are essentially preserving mistakes forever. And on the most interesting paradoxes I've really encountered in the blockchain systems is what I call a 51% vulnerability, because here's the fascinating part. That is, despite all the sophisticated cryptography and consensus mechanisms, so if more than half of the network's nodes collude, for example, collude to bracket false information, that falsehood can become the accepted truth in the system. So the next slide. So we've talked about this. I will skip it. So the next thing I would stress your attention on is how blockchain is revolutionizing international money transfers, for example. So, for example, I've really spent considerable time analyzing remittance systems, and the current state of affairs is, quite frankly, it is problematic. So you can think about this in the following way. When someone sends money internationally today, for example, they are typically paying around 20% in fees. And that's, I would say, astronomical amount, especially for people sending small amounts to support their families back home. But I've seen firsthand how these high costs impact communities that rely on remittances, for example. And here's where blockchain comes in, and this is what excites me most. That is, using blockchain technology, we can slash these costs down, for example, to approximately 2%. And if just let the thing in the moment, so that's a 90% reduction in costs. And that's not just about the money, because these transactions happen almost instantly compared to the traditional 3 to 5 business days. And here I would like to particularly emphasize the role of smart contracts in this transformation, because these aren't just simple programs, as you understand, and they are sophisticated tools that can handle every aspect of an agreement, and therefore they are useful, very useful in terms of the international and especially cross-border transactions. The next slide. So we have told about that. So now let's talk about the topic that's fundamentally transformed the financial landscape, which is blockchain cryptocurrency, in detail. Let me break down this in a way that connects all the concepts I've discussed so far. First of all, in my view, what makes cryptocurrency fascinating is its dual nature as both a digital asset and medium of exchange as well. Because unlike the physical money in your wallet, for example, cryptocurrency exists purely in the digital realm. But here's what makes it special. It's secured by some of the most sophisticated cryptography we've ever developed. And now let me share something from my experience working with various digital payment systems, for example. What sets cryptocurrency apart is how it handles online financial transactions. Because the cryptographic principles underlying these transactions are remarkably robust. So because I've seen traditional payment systems compromised, for example, but the core cryptographic framework of major cryptocurrencies has remained unbreached. And what I find particularly interesting here, and what I wanted to understand, is how cryptocurrency represents a fundamental shift in how we think about money. Because traditional currencies rely on central authorities like governments or banks, but cryptocurrency operates on a different paradigm entirely, because it's designed to function without any central control, purely through mathematical and cryptographic principles. And when you're working on the financial sector, which many of you will be, I believe, so understanding these distinctions isn't just academic, it's essential. So the next slide. And now let us take back to a pivotal moment in financial history, the publication of Satoshi Nakamoto's Bitcoin white paper in 2008. So I remember when it first came out, and believe me, very few people understood its revolutionary potential at the time. And what is very interesting about Bitcoin's creation is how it solved a problem that had stumped computer scientists for decades, like, for example, creating a decentralized digital currency that couldn't be double spent. And that is a very crucial principle. For example, Nakamoto's solution was brilliant in its simplicity, because a proof of work mechanism combined both a fixed supply cap of 21 million coins, not more. And and here is a fun fact, actually, that I love sharing with everybody. When the first real world Bitcoin transactions was for pizza. So as you may know, yes, you heard it right, actually. Someone paid 10,000 Bitcoins for 2 pizzas in 2010. And if we calculate that value in today's terms, well, those were probably the most expensive pizzas ever purchased. So it's a perfect illustration of how far we've come. And what I find particularly significant about the Bitcoin's white paper is how it laid the groundwork for the entirely new financial paradigm. Because it wasn't just about creating digital money, it was about fundamentally rethinking how we transfer and store value in the digital age. And the principles outlined in that white paper continue to influence blockchain development today so far. Because when you are analyzing new cryptocurrency projects in your future careers, for example, I think you will often find yourselves referring back to these fundamental and foundational concepts that Bitcoin introduced. And now let me explain what makes cryptocurrencies truly unique in the world of finance. Because having worked with both traditional and digital currencies, so I can tell you that the differences are really fundamental and fascinating. And one of the most intriguing aspects, in my experience, for example, that cryptocurrencies have no intrinsic value in the traditional sense, of course. And unlike gold, for example, or silver-backed currencies of the past, they aren't supported by the physical commodities. And this really often raises eyebrows in the traditional finance cycles, but it's actually a feature, not a bug. And I really think it's revolutionary concept. And you see, for example, when you work in a traditional banking, for example, so you can observe that every transaction had to go through multiple layers of centralized control. But with the cryptocurrencies, it's completely different. So the supply and governance are completely decentralized, and no single entity, not a government, not a central bank, nobody controls it. And here what I would like you to really understand, so that cryptocurrencies exist purely in digital form. So this isn't just about replacing paper money with digital numbers. So it's about creating an entirely new form of value transfer that's native to the digital world. The next slide we continue with, so it's devoted to the blockchain currency. And so let me share with you what I consider one of the most revolutionary aspects of blockchain currency is its ability to eliminate intermediaries from financial transactions. And for example, from my years in traditional banking, I can tell you just how transformative this is. So the key characteristic that is the most interesting for me, for example, about blockchain currency is its so-called immutability. So what does it mean? So once a transaction is recorded, it can be duplicated or altered. So this is fundamentally different from traditional digital payments, where, believe me, duplicate transactions and fraud are constant concerns. And for example, my consultant practice, I've seen how this feature alone has transformed how businesses think about digital transactions. So, and what really excites me here is peer-to-peer nature of these transactions. So you can think about it when you send money traditionally, it goes through multiple intermediaries, your bank, a clearinghouse, the recipient's bank, and possibly the others. But with the blockchain currency, it's direct, like handling cash to someone, but digitally and securely. And here's what I want you to grasp. So the absence of the middleman isn't just about convenience or cost savings. In other words, it represents a fundamental shift in how we think about the trust in financial transactions. So in traditional systems, for example, we trust intermediaries, for example, in order to validate transactions, but in blockchain, we trust mathematics and cryptography. And this direct transactions capability has implications far beyond simple payments. So in your future careers, for example, you will likely to see this principle applied to various financial instruments and services, fundamentally changing how we think about financial intermediation. The next slide. So, cryptocurrency stability and value driven by user activities and complex governing protocols is the next issue. So now let me explain something fascinating about how cryptocurrency value and stability work. So it's quite different from traditional currencies, and understanding this is really crucial for your future in finance. And in my experience as well, working with both traditional and crypto markets, for example, I have observed actually that the dynamics of cryptocurrency value are uniquely dependent on two key factors. So the first one is user activities, and the second one is protocol governance. So unlike traditional currencies where central banks control supply and value, cryptocurrencies operate on what I call a programmatic consensus. So let me now emphasize something practically important about miners. So they're not just processing transactions, but they are fundamental to the entire ecosystem stability. And for example, I had an experience working with several mining operations, and I can tell you that their role is far more complex than most people realize, for example. And because they are performing sophisticated computing functions that not only record transactions, but also secure the network and maintain its integrity. And what is another interesting thing is the incentive structure. So miners receive newly created cryptocurrency units and transaction fees as rewards. So this isn't just compensation, but it's a carefully designed economic model that ensures the system's sustainability. So, and in different analysis of various cryptocurrencies, so we can see how different reward structures can significantly impact network stability. And for example, if somebody of yours going to work in the cryptocurrency markets, I think the understanding these protocols isn't just academic, so it's essential for predicting market behavior and assessing cryptocurrency projects. Also, now let us walk through this fascinating diagram that really illustrates the entire life cycle of a cryptocurrency transaction. So this is one of my favorite diagrams, actually, because it perfectly captures the elegant simplicity of how cryptocurrencies work. Starting at the top left, you can see that everything begins with a transaction request. And in my experience, implementing blockchain systems, for example, this is where we can come up to the mostly magic things. So the request gets broadcast to what we call a P2P network. So think if it's a vast web of computers all working together to validate transactions. And what is really elegant here is validation process in the middle of the diagram, as you can see. So I hope you can see these nodes, and each one is independently verifying the transaction using sophisticated algorithms. And for example, as for my experience, I can tell you that this is radically different from how conventional transactions are verified. So you can notice the bottom part of the diagram, for example, where it shows three key characteristics of cryptocurrency. For example, no intrinsic value, no physical form, and also no central control. And this is really crucial to understand. We are dealing with a completely new paradigm of value exchange here. And here, the most impressive part, in my view, is how the verified transaction gets added to the blockchain because it's permanent and unalterable. As for my experience, for example, uh, so there is no batch. There is no database system that match the immutability of blockchain as this is. So, and here you can see the orange block on the chain. So once it's there forever. That is a principle of blockchain. And I wanted to pay special attention to how this entire process happens without any central authority, even so you should understand actually this decentralized architecture and how it might be crucial for your work, for example, if you work with the blockchain technologies. So the next slide. And now let me explain one of the most fascinating aspects of blockchain that sets it apart from the traditional system. So it's the remarkable thing about blockchain is its complete transparency in transaction tracking. So you can imagine being able, for example, to see every single transaction that has ever occurred with a particular cryptocurrency unit since it was created. That's exactly what blockchain enables. And when I talk about this kind of transparency, I mean that anyone, anywhere in the world with an internet connection can examine these transactions. So this isn't just about visibility through, so it's about creating a truly global ledger system. And you can think about it in this way. So the entire transaction history is replicated and stored on computers worldwide. And what makes this particularly powerful is that this is global distribution. It isn't just for show. So each copy of the ledger serves here a verification point, making the system incredibly resilient. And if one computer goes down, for example, or is compromised even, thousands of others maintain the accurate record. If I gave you a practical example, so I would say the following. When you make a Bitcoin transaction, for example, it doesn't just get recorded in one central database. Instead, it gets copied to thousands of computers across the globe. And this means that to alter any transaction record, someone would need to simultaneously hack not just one, but the majority of these computers, making it virtually impossible to manipulate the system. And otherwise, this global replication combined with the transparent access really creates what we call a trustless system. So it's not because there is no trust, but because the system is designed in such a way that trust is built into its every architecture. Now, the next slide. Now, let us dive into what makes blockchain truly secure against hacking attempts. So I wanted to share. I want to share with you two critical features that make blockchain such a formidable security system. So first one, let me explain the ingenious way transactions are protected. Here, every block in the chain is connected using advanced cryptography. And you can think of it how it might be, for example, a digital lock that's virtually impossible to pick. And what is very interesting about this structure is that if anyone tries to alter even a single transaction, they would need to change every subsequent block in the chain. So, which is practically, as to me, which is practically impossible given the computational power required. And one of the example of using blockchain system here may be the following. So every 10 minutes, all completed Bitcoin transactions are gathered together and sealed into what we call a block. And it's like talking about the snapshot of all the financial activity that happened in the time window. So once that block is sealed and added to the chain, it becomes permanent. And what is really interesting here about the system is how it creates what we call immutability as well also. So which means the inability to change historical records. And you can see that each block contains a cryptographic reference to the previous block, creating an unbreakable chain. So because of that, if a hacker wanted to change a transaction from last week, for example, they would need to recalculate every single block that has been added since then. And so do it faster than new blocks are being created. And here the computational power required makes this practically impossible. This is why I often tell my students, for example, that blockchain isn't just secure, it's revolutionizing our entire concept of digital security. The next slide. Now let me introduce to the Bitcoin, which is perhaps the most revolutionary application of blockchain technology to date. So, and I want to emphasize three fundamental characteristics that make Bitcoin unique in the world of finance. First and foremost, Bitcoin represents something entirely new in our financial history. So it's a purely digital, completely decentralized form of currency. And what is interesting here about Bitcoin is its use of cryptography for security, which is why we classify it as a cryptocurrency. And when I say cryptography, so I'm talking about mathematical principles to secure that even the world's most powerful computers couldn't break them. Then I'd like to highlight an important milestone that Bitcoin has achieved something remarkable by becoming the largest cryptocurrency in the world by market capitalization. So this isn't about size, it's about market confidence and widespread adoption. So because when we look at the numbers, so Bitcoin market dominance becomes even more impressive. And the next and the third point I want to emphasize is how Bitcoin operates on what we call a decentralized ledger system, the blockchain. Sorry. So you can think of this as a digital record book, for example, but instead of being kept in one place, it's distributed across thousands of computers worldwide. And this system is used for everything Bitcoin related, I would say. For example, creating new Bitcoins, trading them, storing them, managing their distribution, and so on. And what is really remarkable here is that this entire system operates without any central authority. So no government, no bank, no single entity which may control it. And this revolutionary approach to currency is why I believe Bitcoin has fundamentally changed how we think about the money in the digital age. The next slide. So now let us consider how Bitcoin actually works in practice. So you can look at this diagram on the right of the slide and it illustrates the system's simplicity. What you are seeing here is a representation of Bitcoin's peer-to-peer technology in action. And at the heart of the system, we have Bitcoin miners. These are computers running the Bitcoin code and maintaining the blockchain. And here is very interesting how these miners act in the system as systems validators, for example, processing every single transaction that occurs. And now let's follow a typical Bitcoin transaction. For example, you can imagine a sender on the left side of our diagram, for example, wanting to transfer Bitcoin to a receiver on the right. So therefore, the transaction gets broadcast to the network of computers running the Bitcoin code, and these miners then compete to validate the transaction by solving complex mathematical puzzles, which is called a process. This process is called proof of work. And what makes this system revolutionary is the transparency and security it really provides. For example, if you look at how the blockchain connects everything, for example, from individual users to exchange and traditional banking systems, you can understand that. And every single transaction here is recorded in blocks, and these blocks form a chain that every computer and the network can see. And I would say that the beauty of this system is that it eliminates the need for traditional intermediaries while simultaneously maintaining absolute security. And each block in our blockchain contains, for example, information about multiple transactions, making the entire system both efficient and even virtually impossible to tamper with. So the next slide. So now let us delve into a crucial aspect of the Bitcoin ecosystem, so which is the miners and the concept of Bitcoin's limited supply. And this is one of the most ingenious elements of Bitcoin's design that I really find particularly compelling. So let me start with the miners. And as I said before, these aren't people with big access, but they are individuals or companies operating powerful computers that process transactions on the blockchain. And otherwise, in my view, they're essentially the backbone of the entire Bitcoin network, because without miners, for example, the system simply couldn't function. And they are really responsible for validating every single transaction and maintaining the integrity of blockchain. So one thing is really interesting here is how Bitcoin's creation is tied to this mining process, because, for example, you see new Bitcoins are just created out of thin air. So they are released as rewards for mining, for sure. But here is the brilliant part, I would say, because Bitcoin has a hard cap of 21 million coins. This isn't just an arbitrary number, so it's fundamentally built into Bitcoin code, and it can't be changed ever. So, in other words, this fixed supply is what makes Bitcoin radically different from traditional fiat currencies. Because, where, for example, when I teach this concept, I often contrast it with how central banks can print more money at all. And with Bitcoin, there is no such option. For example, this scarcity is intentionally designed to create price stability in the long term. For example, through we certainly see significant volatility in the short term. So this combination of minor rewards and limited supply really creates what I consider to be one of the most sophisticated economic systems ever designed. Now, let me explain the fascinating process of Bitcoin mining. So it consists actually of four essential steps that I would say work together to maintain the integrity of the entire system. So looking at this diagram on the slide, you can see how each step builds upon the previous one. So the first critical step is transaction validation. So as a miner, when I receive a new transaction, for example, I need to verify it. So I need to verify that it meets all the necessary criteria. And this includes, for example, checking if the sender has sufficient funds and if the digital signatures are valid, for example, the following things. And it's like being, in other words, a digital bank teller. But the verification process is completely automated here and foolproof. So, and the second step here involves something we call the proof of work. And this is an algorithm, some kind of algorithm. These things, as to my opinion, are really interesting because, for example, miners compete to solve complex mathematical puzzles that require significant computational power. But I often tell people to think if it's a global mathematical competition where the winners get when the winners have to add the next block to the chain. So, and the third component is what we call independent aggregation. Because once a miner successfully solves the puzzle, so they get to aggregate or bundle multiple validated transactions into a single block. And this is really crucial for the system's efficiency. And finally, we have the confirmation step, because this is where the network reaches consensus of the validity of the new block. And only after this confirmation does the block become a permanent part of the blockchain. So, and I think the beauty of this system is that it's completely autonomous. So no human intervention is required once the rules are set in place. The next slide. Now let me introduce you to one of the most important practical aspects of using Bitcoin, which is the Bitcoin wallet. So here I would like to explain this concept by drawing a parallel with traditional banking, but with some crucial differences that make it uniquely powerful. So you can think of a Bitcoin wallet as your personal banking interface in the cryptocurrency world. However, unlike a traditional bank account. So your Bitcoin wallet does something quite remarkable. So it generates unique Bitcoin addresses for you. And this is really one of the features I find most fascinating about the technology. And now let me explain how it works in practice. For example, when you first install a Bitcoin wallet on your computer or on your mobile device, it automatically creates your first Bitcoin address. But here's what is special, actually. You can create multiple addresses, and each one of them acts like a separate account with their own balance. It's like having multiple bank accounts, for example, but without any additional paperwork or fees. And what I would like to emphasize here is that your wallet doesn't actually store the Bitcoins themselves. Rather, it stores the cryptographic keys that give you access to your Bitcoins on the blockchain. And you can think of it like having the keys to multiple safety deposits, for example, boxes in a global digital bank. And the really cool thing about this system is its combination of security and flexibility. Because, for example, you can easily receive Bitcoins from others, store them securely, and send them anywhere in the world, for example, all from one interface. And moreover, unlike traditional banking hours, the system operates 24/7 and 365 days a year. That is really cool. So now let me address one of the most common questions I got from the students about Bitcoin. It's just how secure is it really? And the answer to this question, as to my opinion, lies in the remarkable cryptographic technology that underpins the entire system. So, and what is really interesting here about the Bitcoin security is that it uses the SHA-256 algorithm. So, and this algorithm actually was really actually developed by the U.S. National Security Agency. It's very interesting. So applying to the theory that Bitcoin was invented by the U.S. government, for example. So we can think about this hypothesis. But now you might wonder why this is significant, really, because if I shared something mind-blowing to you with you, so this might be the algorithm that creates a level of security that's almost impossible to comprehend. So let me put this in perspective to you. For example, to crack this encryption, you'd need to test around 2 powered by 256 different combinations. And that's such an astronomically large number that it exceeds the number of atoms in the observed universe. So when we talk about that, so we often struggle to grasp just how secure this makes Bitcoin. But here's what makes this even more interesting. This incredible level of security isn't just theoretical. So it's being tested every single day by entire global network of Bitcoin users. And so far, the cryptographic protocol has never been breached. So this is why I can confidently say that for example, when we are talking about the cryptographic security of Bitcoin itself, the risks are virtually non-existent. And finally, of course, there are other types of risks associated with Bitcoin. but I think that understanding cryptographic technology is really practically unbreakable without our current computing capabilities. The next slide. Now, let me walk you through the economic model that makes Bitcoin truly unique. So, and here, what is particularly brilliant about Bitcoin's design is how it carefully controls the creation of new coin through, for example, a process that both might be predictable and mathematically precise. So now let me explain how this works in practice. For example, new Bitcoins only come into existence through the mining process, and it happens every time the new block is created. But here's the clever part. That is the rate at which these new Bitcoins are created follows a strict and predefined and predominant schedule that's built into the code. And another interesting thing is here is a halving mechanism. What does it mean? So every 210,000 blocks, which works out to roughly every 4 years, something remarkable happens. So, and that is the number of new Bitcoins created per block is cut in half. So, and this is what we call the halving event. Now, let me give you a specific example of that. For example, during the first 4 years of Bitcoin existence, miners received for about 50 new Bitcoins for each block they created. And after the first halving, this dropped to 25, then to 12.5, and so on. And this systematic reduction in the rate of new Bitcoin creation is what economists call a disinflationary model. So it's completely different from traditional currencies where central banks, for example, can create new money at will. And here in the Bitcoin case, the rules are set in stone from the beginning, even. Because creating what I believe to be one of the most sophisticated monetary policies ever designed. The next slide. So now let me share with you one of the most fascinating aspects of Bitcoin's long-term economic design. And now we are looking at a remarkable milestone in the history of currency. That is a mathematically certain future that extends over a century ahead. And as of now, for example, approximately 13.44 million blocks have been mined in the Bitcoin network. But what I find truly remarkable here is that the precise cap that's built into the system. Because, for example, by the year 2140, and yes, that's true. So we are going to reach exactly 21 million Bitcoins in circulation. So no, it's not 21 and 1.1 or 20.9, for example, but it's exactly 21 million. And this precision is what makes Bitcoin monetary policies so unique. But here, there's an interesting thing, another interesting thing. So, for example, you might wonder what happens after all Bitcoins are mined. And well, this is where Bitcoin economic model shows in its brilliance, because after 2140, miners won't receive new Bitcoins as rewards, but they will still be incentivized to maintain the network through transaction fees. So it's like transitioning from a gold mining economy to a service economy, but it's all planned out in advance. And when I explain this, for example, I usually emphasize how this creates a perfectly predictable supply curve. For example, something that's never been possible with any other form of money in human history. And this, on the other hand, it's this predictability combined with absolute scarcity really makes Bitcoin a fascinating experiment in monetary economics. So now let me share with you some remarkable statistics that demonstrate just how significant cryptocurrency has become in our global financial system. So what we are witnessing is nothing short of a financial revolution, I think, because when I tell about cryptocurrencies market capitalization, for example, reaching $3 trillion in 2021, so many people are astonished even because you can think about what this number means for a moment. It's larger than the GDP of many developed nations. And this really isn't just impressive growth. It's a clear indication that cryptocurrency has moved far beyond its origin as the niche technology experiment. And what I find here particularly fascinating is really how this massive valuation reflects cryptocurrency potential. For example, in order to achieve something unprecedented, for example, the status of a global reserve currency. And this isn't just speculation anymore. So we are seeing major financial institutions and corporations also, and even countries which are beginning to treat cryptocurrencies and legislate financial assets on their base. So, and now let me put this in perspective. Just a decade ago, for example, many dismissed cryptocurrency as a passing fad, but now it's becoming impossible for the traditional financial world to ignore because major banks are, for example, creating crypto trading desks, institutional investors are adding it to their portfolios, and even central banks are exploring their own digital currencies in response. And because this transformation represents one of the most significant shifts in global finance since, I don't know, since the advent of electronic banks. So the next slide. So now let me outline 4 critical aspects that I believe will shape the future of cryptocurrency. As someone who's been studying and teaching about this technology, so I actually find this dynamics particularly fascinating. And first, let's talk about the innovation. So what is the most exciting to me, for example, is the constant development we're seeing in this space, because it's not just about new cryptocurrencies anymore. We are witnessing here the emergence of entirely new applications built on blockchain technology. And the pace of the innovation is simply breathtaking. And secondly, when it comes to adoption, here we are seeing something remarkable because more and more businesses from, I don't know, small shops to major corporations are beginning to accept cryptocurrencies as payment. And here, what I find particularly interesting is how this adoption is even happening across different sectors and geographical regions. And the third aspect I would like to highlight is its resilience, because despite numerous challenges, for example, market crashes, regulatory crackdowns, technology hurdles. No, I don't know. But nevertheless, the crypto economy has shown remarkable staying power, because I've seen it bounce back from setbacks from many thought. I think most of which would be fatal. And however, I must also address here the challenges ahead, because the industry in reality faces increasing revolutionary scrutiny, and rightfully so. And I think we're seeing governments worldwide grappling with how to regulate this new asset class. And there are also technical challenges around scalability and environmental impact. Those need to be addressed as well. So, and now I would like to take you beyond the familiar territory of cryptocurrencies and explore two fascinating blockchain applications that, as to me, are reshaping how I think about digital ownership and organization. So I'm talking about NFTs and DAOs. And now let me start explaining why these innovations matter, because, for example, while Bitcoin and other cryptocurrencies demonstrated blockchain's potential for financial transactions, NFTs and DAOs show us how this technology can revolutionize digital ownership and organizational governance. So, as we deep down into the topic, I want you to think about how these technologies might impact your future professional endeavors. Because whether you are interested in digital art, gaming, investment, or organizational management, so understanding NFTs and DAOs, I think, will give you valuable insights into the evolving digital landscape. And actually, I've been following these developments closely, and I can tell you, as a result, that I think we are witnessing a fundamental shift in how digital assets are valued and how organizations can be structured. So, and the principles we'll discuss today. So, I think they are already being implemented by major companies and innovative startups alike. And what is really interesting here about these technologies, I think it's their potential to democratize both ownership and governance, because through NFTs and by means of NFTs, in other words, digital creators can finally have verifiable ownership of their work, while, for example, DAOs are showing us new ways to organize and make decisions collectively. So now let me break down how NFTs actually work in practice. So think of an NFT as a unique digital certificate, because like a deed to a house, for example, but for digital assets. And what makes it special is that each one has its own cryptographic signature that can be replicated. And the beauty of using blockchain for NFTs, for example, I think it lies in its transparency and immutability. Because when I create when I transfer an NFT, I think the transaction is permanently recorded in the blockchain. It's like having a public notary that verifies your ownership, but it happens automatically and can't be tampered with. So, what is the next interesting thing is that NFTs solve the digital scarcity problem. So because in the past, for example, digital files could be copied endlessly, make it impossible to establish true ownership. But I think with the blockchain technology, we can now create verifiable scarcity for digital assets, giving them real value. And now let me give you a practical example, for example, of that. For example, when an artist creates a digital artwork and mints it as an NFT, so I think they're essentially creating a blockchain-based certificate of authenticity. So even if someone copies the image file, for example, I think they can't replicate the unique token that proves ownership. So that's recorded on the blockchain. And in other words, this infrastructure enables something remarkable. So we can now buy, sell, and trade digital items with the same confidence we have, for example, with the physical goods. And here, the blockchain provides an unbroken chain of custody. I think the custody from the original creator to the current owner. So the next slide. And now let me share some fascinating market insights about NFTs as of 2023. I've been closely monitoring these trends actually, and the data tells an interesting story about where the technology is hidden. And one of the most significant developments I want to highlight is Coinbase NFT platform. And with the anticipated user base of 2 million people, I think it represents the major shift of how NFT are being integrated into mainstream technology, cryptocurrency platforms. This isn't just about numbers, because it's about accessibility and mainstream adoption. And for example, when we look at demographics, so we usually see some interesting patterns, because there is a notable gender disparity in NFT collecting. For example, when men showing higher engagement rates, for example, and someone who studies market dynamics, I find this particularly interesting because it points to potential untapped markets and opportunities for growth. So, and now let's talk about the challenges of the technology. First of all, the market has experienced a significant quarterly trading loss of approximately $450 million. And for example, in my analysis, this isn't necessarily a negative sign, because I think it's more indicative of the market normalizing after the initial hyper cycle. But what is particularly compelling here is how public interest has evolved since 2022, even because now we are seeing a shift from speculative buying to more sustainable and utility-focused applications. And I think this so-called maturation process, while challenging for some investors, but it's actually strengthening the foundation of value of NFT technology. So just a minute break. So let's go on. And now on the slide, I want to introduce you to one of the most revolutionary applications of blockchain technology, which we call decentralized autonomous organizations, or DAOs. And here, in my view, this is where blockchain truly shows its potential to transform organizational structures. Because, for example, let me explain how DAOs work. At their core, I think they operate on the blockchain technology, but what makes them unique is their ability to function without traditional hierarchical management. And instead, every decision is made through smart contracts and community voting. Because as someone who studied organizational structures, so I find this particularly fascinating. And what excites me most about the DAOs, I think, is their automated operations through smart contracts. Because, for example, if you imagine an organization where routine decisions are executed automatically based on the predefined rules, while the strategic decisions are made through a community consensus. So that might be very interesting. And however, I would like to be transparent about this challenge because DAOs face significant hurdles in terms of scalability and, for example, legal recognition. And for example, in my experience, these are typical growing pains for revolutionary innovations because the key applications were seen in the finance and governance, but the potential extends far beyond these areas. You can think about this in that way. So we're witnessing the emergence of organizations that can operate 24/7 and make decisions transparently, but give every stakeholder a direct voice in governance. And this is why I believe DAOs represent a fundamental shift in how we think about organizational structure and organizational management. So the next slide. Now let me share some remarkable statistics that demonstrate just how significant DAOs have become. So as of April, as you can see on the slide, as of April 2023, we are looking at the market capitalization of $22 billion. And to put this in perspective, that's larger than many traditional corporations. And what I find particularly striking is the growth rate, because we are seeing staggering for about 60,000% increase in active DAOs since 2019, sorry. And in my years of studying financial markets, so I've rarely seen such an explosive growth of any sector in any sector. This isn't just about numbers, so it represents a fundamental shift in how people think about organizational structure. And let's look at the community engagement. So I think with the 6.8 million governance tokens holders and 2 million active voters, I think we are seeing unprecedented levels of direct participation in organizational decision making. That is really exciting. So what excites me about these numbers is that they represent real people taking active roles in governance. The treasury assets of, for example, $28.1 billion and venture capital investments of $160 million in, for example, in the first quarter of 2022. I think it tells us something crucial, that institutional investors are taking DAOs really seriously. From my perspective, as a financial technology expert, this institutional buy-in is a strong indicator of the technology potential. I think these metrics overall aren't just impressive numbers, so they really represent a growing confidence in decentralized governance models, because when I took at this trend, so I see a future where DAOs, for example, could become as common as traditional corporations are today. So before we wrap today's lecture, so I want to emphasize these key points that I believe are really crucial for understanding blockchain technology's transformative potential. So, and let me summarize what we have covered. First, we discussed how blockchain emerged as a response to the vulnerabilities we saw in centralized financial systems. And what makes this particular significance is its ability to create decentralized, transparent ledgers and don't require trust in the central authority. And we then explored how Bitcoin pioneered the practical application of the blockchain through proof of work mining, because this was followed by Ethereum's revolutionary introduction of smart contracts, but which I believe was a game-changing moment that opened up entirely new possibilities. And what I find most exciting is how blockchain is now being deployed across multiple sectors, because from my experience, for example, working with various industries, so I've seen firsthand how it's transforming everything from supply chains to healthcare. And here the applications in identity management and payments are particularly promising. And finally, I want to acknowledge the challenges we discussed. For example, particularly around scalability and energy consumption, because however, as someone who's been studying this technology since its early days, so I can tell you that these challenges are driving rapid innovation in the field, and the capabilities are evolving at the unprecedented pace. So here is a very short quiz. Please take several minutes to answer the question. So the question is, which of the following features of blockchain technology make it uniquely suited to secure and decentralized digital transactions? Please put in your answers into the chat, and let's take, say, a couple of minutes for that. So, well, I see your answers. Yeah, that's good, actually. So so you think the right answer is third? So let's look at. Yeah, thank you very much for your answers. So, and you're quite right. So the correct answer is 3. So the next one, here you can find a few issues for discussion. So we are skipping them right now, but you can take them, for example, to think about as a homework. And if you wish, so we could discuss it afterwards, for example, at the end of the current lecture or at the beginning of the next lecture. But nevertheless, please pay attention to these issues, for example, because it seems to me that they might be very useful in terms of understanding the blockchain technology and cryptocurrencies. And here is a short glossary on the topic. So please, any questions on the topic before we move to the next one?